Ladies and gentlemen, today we are going to look at some uh, reactions of organic compounds, starting with combustion reaction. So, ladies and gentlemen, what is combustion reaction? Combustion reaction is a reaction in which hydrocarbons or compounds are born or are breakdown in the absence of oxygen or in a limited supply of oxygen. So the combustion reaction can take place in two different ways. In the presence of excess oxygen, the hydrocarbon, like for example here methane, break down to produce carbon dioxide and water. So whenever we say combustion reaction, two things must come into our mind. Number one, it can take place in the presence of excess oxygen, and it can also take place in the presence or in the limited supply of oxygen. So in the presence of excess oxygen, hydrocarbons generally break down to produce carbon dioxide. So that is the first thing that we need to put at the back of our mind whenever we say combustion reaction. So it's a reaction in which compound break down, especially hydrocarbon, to produce carbon dioxide and water. So always if you are given a reactions where you see oxygen and carbon dioxide, and from there the first product that will come into your mind is carbon dioxide and water. But in the limited supply of oxygen, when the oxygen is limited, so hydrocarbons generally react with oxygen to produce carbon monoxide and water. So carbon monoxide is CO and water. So that is for the combustion reaction. So combustion reaction is one of the reaction of organic compounds, and for the purpose of this class, I'm actually going to look at the brief introductions of these reactions of organic compound. Is brief, and we are going to look at them very well in depth, including their mechanisms of action. So now then another types of reaction is substitution reaction. Substitution reaction is actually involve saturated hydrocarbons. So it's mostly for saturated hydrocarbons, because when we say substitution, because the compound is saturated, so it doesn't need to accommodate more electrons. So that is why whenever we talk about substitution reaction, the first thing that will come into our mind is alkenes, because alkenes are saturated hydrocarbons. So what happens in substitution reaction? One or more hydrogen gets replaced by another atom or group, and compare the number of hydrogen on the reactant and the product side. So you see now we have methane CH4. We can see that in the reactant and the product, one atoms of hydrogen is removed, and we now have CH3Cl, and we call it chloromethane plus hydrochloric acid. So we have mechanisms of also substitution reaction, but as I said, we are going to look at it briefly in this class. And these three mechanisms involve initiation and terminations reaction, although before termination we also have I think actually we are going to look at them very well one after the other, but for the purpose this is just an introduction. So whenever we say substitution reaction, it means that one atom is replaced with another, because it doesn't need to accommodate more number of elements, so or atoms. That is it. Then the next types of reaction that we are going to see is addition reaction. So here when we said addition reaction, it means that they are not saturated, they are unsaturated hydrocarbons, and they need to accommodate more number of electrons. And generally when we talk about addition reactions, we usually break down pi bond to create more number of sigma bond. So now you can see that in this it involves an unsaturated hydrocarbon. So remember when we said unsaturated hydrocarbons, we means alkenes and alkynes. And when we said alkenes, they have double bond and they have deficiency of only two hydrogen atoms. And when we said alkynes, it means that they have the efficiency of four hydrogen atoms. So here, of course, chlorine uh, will be added here. So we can see that we are moving from unsaturation to saturation, and look at it. And this we see that, look for the two reactants and the one product. So the two reactants are chlorine and the ethene. So we can see that it now changed to 1,2-dichloroethane, because at carbon 1 we have chlorine, and also at carbon 2 it's now changed to 1,2-dichloroethane. So we see that two chlorine atoms are now added across the double bond here. Let me just give some demonstration here. So that what actually happened now is, as I said, let's look at this one, and how it is we can clearly see that one atoms of chlorine is now added to here, and the other atoms of chlorine also is added here. So one of these bond is pi bond and the other one is sigma bond. So you can see that two sigma bond are created and one pi bond is being destroyed. So you see that the number of sigma bond will be increased. How do we get the number of sigma bond here? We count the number of atoms. There are 6 here, all the atoms, 2 carbon, 4 hydrogen, so there are 6 atoms. So 6 minus 1, we have 5. So it means that we have 1 sigma bond. And here we count the number of atoms in total. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. So if we now see 8 minus 1, we have 7. So we have 7 sigma bond. So therefore, whenever you destroy, or you destroy one pi bond, so you always create two sigma bond. So that is this. So that is for addition. And actually, as I said, this is brief. So when we said addition reactions, a lot of things we are going to look at them. Number one, under addition reactions, we have like hydrogenation, hydrohalogenation, chlorination, nitration. We have actually many of them. But for the purpose of the class, we are just trying to give an introductions of all this. Then the next thing is esterification reaction. So whenever we said esterification reaction is a reaction between organic acids and organic base to generate alkaloids and water, and these alkaloids we call it ester. So look at it, we have acetic acid react with methanol to produce methyl acetate plus molecule of water, and this acid is acetic acid, or we can call it ethanoic acid plus methanol. So we'll end up of having methyl ethanoate, which is the ester. So we are also going to look at this esterification reaction very well, and we are going to look at how we can even name the esters. The ester, yeah, you see, an organic acid and organic base make an ester and water, and should be able to recognize the acid group and the hydroxyl group in the reactant. You see, remember yesterday, remember we talk about acetic, when we talk about alkanoic acid, they have functional group of COOH, and for that of the alkanol, they have OH group. And of course, the methyl acetate, which is methyl ethanoate, uh, is alkanoate, that is the ester, of course. Okay, then now the next thing is saponification reaction. Is also organic reaction. When you say it, a saponification, a fat react with a base to produce alkanol, or look for a glycerol and a sulf. So generally, whenever we undergo saponification reaction, is a reaction that we usually produce sulf in the industry, where ethanoid is where ethyl steroid or alkanoid react with a base to produce the sulf and the glycerol or alkanoids, yeah, generally. So that is saponification reaction, the reaction between fat to produce base and fat and base to produce sulf and alkanol. So it's like hydrolysis, it's like alkaline hydrolysis, it hydrolyzes fat. Yeah, so we use saponification reaction in the industry to produce soft. And then the next thing is fermentation reaction. So fermentation reaction is actually a series of reaction that leads to breakdown of glucose in the absence of oxygen to produce ethanol and carbon dioxide. And this is one of the method we use in the industry in producing alcohol, yeah, is fermentation. And this fermentation is usually taking place in the presence of enzymes and some microorganisms. So it usually take place under anaerobic condition, that is in the complete absence of oxygen. Then polymerization reaction. So okay, I think let me just stop here, we'll continue later. Polymerization reaction uh, is when we have an unsaturated hydrocarbon called monomer and bond itself in a long chain creating a polymer. So a smaller unsaturated hydrocarbons that joined up together to produce a bigger one. So we have addition polymerization and we have condensation polymerization. So in addition polymerization, unsaturated monomers join by breaking their double bond or triple bond to bond with one another, making long chain, and several monomers combine to fire to this. Okay, so and in the condensation reaction, creation of a polymer plus water as a product. So usually when we have condensation, when we have two atoms or two molecules or monomers joined together, a small molecules is released. And this example of small molecules we have like water and other things like that. Okay, so I think this is briefly on the reactions of organic compound. They are in brief, so we are going to look at them very well. Okay, thank you. And if you want to, and and if you want to get more of this video, I advise you to follow my TikTok, and my and you can also get it on our website as Dararape SCH, Dararape School. So it is there in my logo. You can just get it there. You can just download the application and get everything from there. We have a lot of courses: organic chemistry, inorganic chemistry, mathematics, biochemistry courses, physiology, anatomy, and the rest. So thank you for listening.